Hi everyone, in this video we would like to discuss the characteristics which measures the performance of the relay. So what are the characteristics which measures the relay performance? Number one, the selectivity of the relay. Number two, sensitivity. Number three, reliability. Number four, dependability, security, and adequateness, and of course the speed. Now the characteristics here for the relays, those characteristics here representing the one which measures the relay performance, if it is good or bad or whatever. So let's see each of them or the definition of each of them. So number one, the selectivity. So what does the selectivity means? The protective system should be selective in protection, meaning the protective relaying should select the faulty part of the system and isolate only the faulty part from the remaining healthy system. So what does this mean? It means that if we have a fault at F1 here, so the circuit breaker or the relay itself, the relay which is related to circuit breaker number 1, should only isolate the faulty part. If a fault occurred here, therefore it should only operate and isolate the fault here. So here we are isolating the faulty part from the remaining system. So only circuit breaker 1 should open, and circuit breaker 1 will open according to the instruction from the relay number 1 which is related to him. Now for a fault number 2, fault here number 2, at this line, therefore circuit breaker number 3 and circuit breaker number 2 should only trip and isolate only this faulty line. So according to the relays related to them, they can only be the one who isolate. So the selectivity means here is that we are selecting only the faulty part and isolating it from the remaining power system. The second one is the sensitivity. So says the sensitivity of the protective scheme, and we'll understand later what is the meaning of the protection scheme, refers to the smallest value of actuating quantity at which the protection starts operating in relation with the minimum value of fault current in the protected zone. So what does this mean? It means that in the sensitivity, it means that our relay should be sensitive to the fault occurring to the region or the protective zone of it. So as an example, the protection system of the transmission line L, which is this line which contains circuit breaker number 3 and circuit breaker number 2, should be so sensitive, this protection system of this line, that it should respond to a fault, say F2, for a minimum fault current. So if a fault occurred here, so that the relays here should be very sensitive to the value of the current which is considered as a short circuit or a fault current from their perspective. So the smallest value of the short circuit here, the relay should be sensitive to this and trip the two circuit breakers. So the sensitivity means that the relay or the protection system should be sensitive to the fault occurrence. The sensitivity is measured by or can be defined in the terms of a factor called the sensitivity factor, Ks. Ks, which representing the sensitivity factor, is the ratio between the minimum short circuit current occurring in our protection zone over the minimum operating current of the relay, which is the backup current. So Ks, or the sensitivity factor of the relay, representing the Is over I naught, where Is is the minimum short circuit current in the protection zone and I naught is the minimum operating current of the protection device or the relay. So here this value or the ratio between them representing the sensitivity of the relay or the protection device. Now another component or important characteristics for the relay is the reliability. So the reliability is generally understood to measure the degree of certainty that a piece of equipment will perform as intended. So this is the general definition for the reliability. It means that the degree of certainty that the equipment will perform as intended. And what we mean here by reliability, the relay itself should be reliable. And what does this mean? It means that we can rely on our relay. So when a fault occurred, the relay should trip, and when a fault does not occur in the protection zone, the relay should not operate. So the reliability means that the reliable relaying system must be dependable and secure. It should have the characteristics of dependability and the security. And we will understand their definition in the next slide. So the reliability, under it the dependability and the security. So the reliability, how can we measure the reliability of the relay? The percentage of the reliability representing the number of correct trips of the relay. So the relay itself will trip, so we need the number of the correct times at which our relay tripped over the number of the desired trip, the number of the desired at which we want our relay to trip, plus the number of the incorrect trips of the relay itself. Don't worry, we will have an example about this, the reliability, dependability, and security, so you can understand how we can apply these definitions. The second definition is the dependability. The dependability is defined as the measure of certainty that the relays will operate correctly for all faults which they are designed to operate. So what I mean here is that our relay will be dependable. I can depend on it. And the dependability of the relay can be equal to number of the correct trips of the relay itself over total number of the desired trips. So how many trips that I want or the relay should have tripped. But number of correct trips representing the number of the actual trips or the actual correct trips for the relay. The third definition is the security. Security is the measure of the certainty that the relays will not operate incorrectly for any fault. So what does this mean? It means that the ratio between number of the correct trippings over the total number of trippings. Total number of trippings representing the correct plus incorrect trippings. So here what does a secure mean? It means that if a fault occurred in a zone outside the relay zone, so occurred in another protection zone, so that our relay should not operate in this case. But if it is operating in a zone which is not belonging to, it means that our relay is not secure. Now let's have an example in order to understand the reliability, the security, and the dependability. So we measured the performance of an overcurrent relay. An overcurrent relay is a relay which detects the overcurrent occurrence, such as the short circuit or overloading. So this overcurrent relay was monitored over a period of 1 year. So we analyzed our relay for 1 complete year during its operation. It was found that the relay operated 14 times. So 14 times representing the number of the correct trippings plus the number of the incorrect trippings for the relay. So the relay tripped 14 times during the whole year, out of which 12 were correct trips. So 12 were correct and 2 were incorrect. So 14 times tripped, 12 times there was an actual fault, but 2 times was no fault. It was wrong trip. If the relay failed to issue trip decision on 3 occasions, compute dependability, security, and reliability of the relay. So here there was 3 times where we had faults in our system, but the relay did not operate. So the 3 times is a time or the number of trips at which our relay did not operate, but it was or should have tripped. So the dependability, we said that the dependability equal to number of correct trips over the number of desired trips. The correct trips here, we said that the relay tripped 12 times were correct trips. So the correct is 12. What are the number of desired trips? The relay should have tripped 12 times, which is the correct trips, plus the 3 times or the 3 occasions in which it failed to trip. So the total of them is 15 desired trips. So 12 over 15 gives us 80%. So y, number of desired, representing the 12, which is the correct times, plus the 3 occasions when the relay failed to issue that decision. The security, representing the number of the correct trips over the total number of trips. So the number of correct trips is 12. Total number of trips of the relay, how many times did our relay trip? 14 times. So 12 over 14 representing 85.71%. The reliability of the relay, representing number of correct trips over number of desired trips plus number of incorrect trips. Number of the correct trips, how many correct, is 12. Number of the desired, how many desired trips? The desired was 15, because 12 plus the 3 failed occasions, so 15, plus number of the incorrect trips. We had how many incorrect? We had 2 incorrect trips, because out of the 14, 12 were correct and 2 was incorrect or were incorrect. So 12 over 17 give us 70.59%. So you will find that the dependability 80%, security 85%, which is above 80%, which representing a good values. However, the total over the all reliability is 70%, which means that this relay is having a poor reliability. It is not reliable because it has a low reliability here, less than 80%. Now another example here, for a fault at F here, if a fault occurring here, therefore the relay number 1 and relay number 2 should give signals to circuit breaker number 1 and breaker number 2. So if a fault occurred here and these 2 relays worked, therefore what does this mean? It means that our relays are dependable. They tripped during the presence of a fault in their region. Now, if the relay number 2, for example, does not operate for this fault, it becomes unreliable through the loss of its dependability, because we cannot depend on it, because it lost its dependability, because it did not operate when a fault occurred in its region. But what will happen if a fault at F here and relay number 5 operated? Okay, relay number 5 operated before R1 and R2. So what does this mean? It means that our relay number 5 is unreliable too. Why? Because it lost its security. Becomes unreliable through the loss of security. Why? Because it operated outside of its region as a primary one. Here the fault occurred, so R1 and R2 should clear the fault. And the other R3 and R4 are the backup. But R1 and R2 should operate, and then R3 and R4 if they did not operate as a backup. So when R5 operated, it is not outside its region. So R5 operation as a primary one is a loss of security because it operates outside of its original region. Another characteristic for the relay is adequateness. So the relay should be adequate. What does this mean? It means that for the low voltage machine or equipment at the remote end of the system or at the end of the power system, A costly protective system is not necessary. We should not here provide a costly protective system, and we'll understand what does this mean. For example, the distribution transformer, say below 500 kilovolt or less than 0.5 megavolt ampere, should be protected simply by drop-out fuses. They should be protected by a cheap fuses, not of course a relay, circuit breaker, and this protection scheme, because this relay, circuit breakers, and this protection scheme is costly and can be equal to the cost of the transformer itself or higher. So we should protect it by a simple and cheap system, which is the fuses. Now also the motors below 120 horsepower are protected by thermal overload relays and high rupturing capacity fuses. So this type of fuses is used to protect it against short circuit and thermal overload relays when the current exceeds the certain value or overloading occurs. Heat dissipation will occur, and this will cause the relay contacts or the contactor or the contacts of the motor itself will be separate from each other due to the presence of excess heat, or due to the presence of the supply of excess current, which will cause excess heat. So we protect our motors which have low HP below 120 horsepower by fuses for short circuit and overload relays for overloading, or when we exceed 100% or 110% according to the value or the setup value for the protection system. In these cases, the cost of the CTs or the current transformers, protection relays, circuit breakers, and etc. is not generally justified. The cost of all of this can be higher than the distribution transformer or the motors below 120 horsepower. Now, whereas for the large machine, say a generator, a very complex protection system is required. So, protection against insulation failure. Inside the machine itself, the insulation failure can occur due to the presence of overvoltage or heat or thermal overloading. The stator earth fault protection for the generator itself, the rotor earth fault protection, the unbalanced stator loading protection, the protection against stator overheating, overspeed protection, differential protection. So all of this type of protection can be used to protect a large machine like a generator. Remember that the generator have for example, a synchronous generator having its stator and rotor. So we have to protect our stator and rotor against earth fault, which means that the winding itself, any of the windings is connected to the earth or connected to the ground. Protection against insulation failure due to overloading or due to the presence of excess heat, which will cause insulation failure, or presence of overvoltage. Unbalanced stator loading protection, which means that when the stator itself, which produces our three-phase power, if the currents in the stators are not balanced, the current flowing inside the stator are not balanced, this will cause inside the rotor also different problems, which will be discussed in the lecture. We will discuss the generator protection in details, or the protection scheme for the generator itself. And of course the stator overheating, of course for the if the temperature exceeds a certain limit, overspeed protection to protect the rotor itself from having overspeed, the differential protection, and against the differential protection is used for the internal faults inside the generator. And we'll also discuss the differential protection in details in another lecture. The last characteristic is the speed. As the current increases, the time of the operation should decrease, because as the fault current increases, we need to isolate the fault as soon as possible. So the time should be decreased as soon as possible, or decreased to a very small value to prevent the melting of the conductors or any problems occurring inside our equipment. So we discussed in this video the characteristics of the relay and how we can measure the performance according to them. Thank you for watching this video, and I hope you enjoy it and learn it from it. Now I would like to invite you to my academy, Khadija Academy. You will find the link for the academy in the description for this video. You can find there useful courses, free and paid courses, which will help you as an electrical engineer. So check it out if you would like to learn more about it. Thank you.